Hello everyone. Today in this video we'll be discussing the fourth module of AI/ML 18 CS 71, and in this module mainly we have the concepts regarding the Bayes theorem and the classification. Means in the exam you'll be given with a data set like this, and what you have to do is means this data set will be given, okay, and another data set will be given, like not data set, another values will be given. You have to classify this values belongs to which class. Okay, so those examples I'll be discussing and I'll be telling you how you do write in exam. This is regarding the numerical part. There are two types of numerical in this case. We'll be discussing both of those. One comes in Bayes theorem, second comes in Naive Bayes. Okay, regarding except that there are some theoretical concepts as well as some algorithms. Okay, so these are the algorithms and the derivations which are present, which are super important short questions from exam point of view. So while watching this video, make sure you concentrate on each of these algorithms and the numericals. I'll be telling you the key points. Make sure you note down them and practice before going to exam. So let's get started with the first topic, which is Bayes theorem. Okay, in Bayes theorem, how many type of question can be asked? Three type of question can be asked. Okay, so the three type of questions in the Bayesian Bayes theorem is, before knowing about the Bayes theorem and the actual theorem, you need to know from where it came. Okay, what is Bayes theorem and why we are studying it? What's its significance? Okay, so what is Bayesian learning? That's the first question I would like to discuss about, and some of its features. Features you can just go through it. I'll be telling you one keywords in each of these features, so you can go through it easily. Let's talk about what is Bayesian learning. In Bayesian learning, you have some probability calculation. Okay, it is a way of calculating probabilities of the final outcome based on the observed data and the current probabilities. There are two things. Observe carefully. Observed data is what we know about some data features and all, and current probabilities means what is the probability of that occurring in the current situation. Those two things we have. By using these two things, we will be calculating the final probabilities. That is what is called Bayesian learning. When we see the formula and discuss the algorithms and the numericals, then you will get to know what it actually means. For now, just keep in mind. Okay, and features you can go through it. I'll just tell you the key points. Observed training example can be incrementally decreased or increased. Prior knowledge can be combined with observed data. The prior knowledge which you already know about the data can be combined with the observed data. Bayesian methods accommodates hypothesis that makes probable predictions. Okay, it accommodates some hypothesis as well. New instances can be classified by using the Bayesian algorithms. Bayesian methods can provide a standard optimal decision. Okay, so these are one of the features, means these are the keywords for the features. You have to remember the keywords and write the explanation in your own words. Second type of question, these questions are not like exam type of question, just for your reference. Okay, what are the exam type of questions that I will tell you explicitly. Okay, like those only six what topics I showed in the starting part of the video, right? Those are the exam type of questions. Okay, so I have to focus more on that. These are just to give you the information, and in case you forget some main key points, you can write something about these things. What are the practical difficulty in applying Bayesian methods? Is it always easy to apply Bayesian algorithms, or is there some difficulties? What are the practical difficulties? There are two practical difficulties. They typically require initial knowledge of many probabilities. The domain knowledge means if you are going to a school, you need to know the school's name, right? That is the prior knowledge which you need to know. Like that only Bayesian method, the context of what the probability is applied upon, that context you need to know. Significant cost computation, there is a lot of calculations happening, so there is a significant cost computation. These are the two practical difficulties in applying Bayesian methods. Okay, now let's come to the super important question from the exam point of view. Explain the Bayes theorem with proof and example. Okay, so we'll be learning what is Bayes theorem. Bayes theorem gives the probability of an event based on the prior knowledge of condition. This is the main concept which you need to keep in mind. It has a prior knowledge of the conditions. Okay, based on that, it will give the probability of an event. So this is the formula you need to know. P of A given B has occurred. Okay, you have to read like this. Probability of A given B has occurred is equal to probability of B given A has occurred into probability of A divided by probability of B. Each of these term has a separate name. This is called as hypothesis. P of A by B is called as what? Hypothesis. P of B is called the marginal. P of A, which is this one, it is called the prior, and P of B by A is called the likelihood. You need not remember the names, just remembering the formula and applying it sufficient for you. Okay, now let's talk about the proof. After that, we will take an example as well. In the proof, let's take two events A and B. Okay, A and B are the two events with us. So if we use the same formula which I have mentioned above for writing the probabilities of A given B has occurred and probability of B given A has occurred, it will look as follows. Probability of A given B has occurred is nothing but probability of A intersection B divided by probability of B, and this one is equal to probability of B intersection A divided by probability of A. What is at the end, that you will be writing in the denominator, just as same in this case as well, and what is in the top you will will just take as intersection. That's how you will be starting with the proof. After you have written this one, what you will do is you will cross multiply this with this one and this with this one. Then what will remaining with? Will be remaining with probability of A intersection B here and probability of B intersection A here. As you already know, probability of A intersection B and B intersection A both are same, right? If I draw A here and if I draw B here, what is probability of A intersection B? This. Now tell me what is the probability of B intersection A? That is also the same thing. So it's obvious that if these both are same, obviously this cross multiplication with this and this cross multiplication with this, those values should also be same. So that's what I've written here. This value is cross multiplied, I've written here. This value cross multiplied, I have written here. Okay, sorry, I've written here. See, these both are same, so I can equate these both, right, left hand sides. So that's what I've written here. Now I'm concerned with probability of A in, given that B has occurred. So I'll keep it here only. I'll shift this down. When I shift this down, I'll be arriving at the Bayes theorem formula. So this is the proof. You need to practice this. If they ask an exam, you have to write this one. If they ask you about the example, you can consider the simple example of the card example. So here are some more terms explained, so you can go through it. And the example is of probability of getting a king given that face has occurred. Like for example, there is a deck of cards and you took one of those cards and you tell your friend that the card is face card. Okay, the card is face card. Now you have to tell me what is the probability that in the face card it will be king only. What is face card? First of all, face card consists of joker, king and queen. These three types of cards are called as face cards. Now I am telling you that face card has occurred. Now you should tell me the probability. What is the probability that king will come in the same card? Okay, so how we will be approaching this is, first what we will do, we will calculate how many total cards are there. There are 4 jokers, 4 kings and 4 queens. So 4 into 3, 12. Totally there are 12 face cards. Okay, so according to the formula, I will be writing P of face by king into P of king divided by P of face. Now what is P of face by king? If I tell you that I got king, what is the probability that I'll get face? This doesn't make any sense only, because obviously king is face only. So this probability will be 100%, right? If I tell you that in the box there is a black ball, okay, so and all other boxes have white balls. Okay, let's mention it A, B and C. In the B block, in the B box there is a black ball. Now I tell you that I have got a black ball. Now tell me the probability that it is from box B. Obviously you will be telling 100% because that's the only possibility. Similarly, if I tell you that I've got a king card, obviously king card belongs to face cards group, so obviously getting a face card is only 100% because already I've got king which is face, right? So that is 100% probability. So I'll have written 1 here. Probability of king means there are 4 kings out of 52 cards, so 4 by 52. P of face means how many face cards are there? 12 are there out of 52, so 12 by 52. Simplifying, you'll get 1 by 3. That means if I got a face card, there is a 1/3 possibility that I'll get a king card. What is the next 1/3 and next 1/3? Another 1/3 is reserved for joker and another 1/3 is reserved for queen. So 3 types are there, so each will get 1 by 3 possibility. This simple example for the implication of application of Bayes theorem. Okay, we are done with the first topic. So what we will be doing is, whenever we have done a topic, we will be tick marking it. Okay, so moving on to the next one, we have ML, which is maximum likelihood, MAP is maximum posteriori, and LS is least squared. Okay, so we'll be discussing the proofs regarding this in the upcoming topics. So let's get started with the second one, which is ML. Before that, you need to know what is Bayes theorem's concept learning. Okay, what is the relation between Bayes theorem and concept learning? Bayes theorem calculates the probability of each possible hypothesis and outputs the most probable one. This is what the Bayes theorem does, and this can be implemented in machine learning using the term concept learning. For that, we have the brute force method. You got the connection now? For implementing this, we will be learning concept learning. Okay, so in the brute force, for each hypothesis in H, calculate the posterior probability. Okay, for each probability in H has many small probabilities like small h1, small h2 and so on. Okay, by that we will be calculating the posterior probability. So we'll be writing the formula P of a small h in the given D training set is equal to probability of D given H has occurred, probability of H by probability of D. This is the first thing we will be writing for brute force. Then what we will be writing, output the hypothesis which has H map, which is the maximum likelihood or the maximum posteriori. Okay, which is the highest probability. H map is equal to argument max small h belongs to the capital H, which is the most probable one, most likelihood that will be outputting. Okay, to calculate we need the values of ph and pdh. Some assumptions are as follows. Training data D is noise free, this is the first assumption. Second is target concept should be present in hypothesis space. Third is there is no prior reason to believe any other hypothesis is more probable than any other. All the hypotheses is equal is the third assumption. So we'll be starting as follows. P of h is equal to 1 by capital H. Okay, for all small h in capital H. Then P of dh is equal to 1 if di minus h of xi for all di in d, otherwise 0. Okay, after we have written this one, we'll be calculating what is the value of this one and what is the value of this one. After that, we'll be substituting something in the place of 1 and 0. From case 1, there are two cases. Hypothesis H is inconsistent, hypothesis is consistent. In hypothesis is inconsistent, P of d by h is equal to 0. So in this value we will be putting 0. So the final answer will be 0 in the case 1. In case 2, the value of P of d by h is equal to 1. These are the cases which are considering, the case 1 and case 2. Okay. So in the second case, when it is 1, in this place we will be substituting 1. So what we will get is ph by pd. Ph is nothing but 1 by h and pd is nothing but vsh d, which is the version space h comma d divided by h. H will get cancelled, we'll get 1 by version space of h comma d. So for 1 what we got, this answer. For 0 what we got, 0 only. So this is what we'll get at the final. This what you have to write if they ask you the proof regarding the base concepts, concept learning using the brute force. Okay. Moving on, we have the evolution of probabilities associated with hypothesis. Okay, these are the subtopics. The main topic I'll tell you before that means the exam point of view, super important topic. So these are the subtopics which you need to know. Evolution of probabilities associated with hypothesis. By the figure itself, you can understand if the hypothesis is spreading all over the place, it will be equal. If it is just in some domain, it will be a higher, but it will be less. Other places it will be 0. If it is very narrow domain, it will be very high in one place, and other places it will be 0. This is the evolution of probabilities based on the hypothesis. Okay, next we have maximum likelihood and least square error hypothesis. This is a super important one. Okay, ML and LS. Okay, to find the maximum likelihood means which is the most probable hypothesis. For that we will be using the Bayesian learning H map. We will be finding out H map value. H map is equal to argmax. Small h belongs to capital H. Probability of small h given d has occurred. Small p, this is the probability density. Before cases we used capital D, that is just the probability. Here it is small p, which denotes probability density. Okay, so we'll be considering two things. Let us take the training instances x1 x2 till xn and consider the target values d is equal to d11 d21 d31 till dm. We write pdh as product of di into h. D is composed of many small d, right? So we'll be multiplying each of these to get the final answer as capital D. Okay, so how we can write it? H map is equal to argmax. This how I wrote this one is in the place of h by d, I'll be writing this one. Okay, DIH. How am I writing DIH? All the possible DI values like D1, D2, D3, D4, all if I multiply, I'll get capital D. So that's why I've written this one, and this is called as product. Like how summation we have, right? Like that only we have product. From I is equal to 1 till m, it will get substituted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till m it will substitute. And it will multiply each of these terms, and then we will get the final D value. By assuming the normal distribution, whenever we have the multiplication values, we'll be assuming normal distribution. And this is the formula for normal distribution. If I have given a function f of x given u has occurred, then 1 by root 2 pi sigma square e power minus x minus u whole square divided by 2 sigma square. This is the formula which you need to keep in mind. And then what we'll be doing, just simple procedure. Di will substitute in the place of x, h we will substitute in the place of u. Okay, just doing the substitution at the end like dix and h in the place of u. We'll be getting the equation as follows. Wherever x was there, I substituted as d. Wherever u was there, I substituted as h of xi. Okay, after we have done that, what we can use is, in this equation you can see there is a very complicated procedure. E power something is there. If you use the natural log, which is ln, what will happen is this e will get cancelled. So when e will get cancelled, it will be written as this multiplied by this whole term. Okay, why? Because log of e power x, that is equal to x log log of e power x is just e power x itself, right? But if you have in the place of x as 2x, we'll be getting 2 log e power x. e power 2x, right? Like this we will be getting. So that's the same thing which we are doing. In the place of logarithm we are writing here, e will get cancelled because it is natural log, and we will be writing the numerator term, sorry, not the numerator, this power term. This power term will be just writing in multiplication with this term, okay? And you can observe here that we are using one formula, log ab is equal to log a plus log b. This is in the multiplied form. This term is getting multiplied with this term. So what I can write it as log a plus log b, okay? And when I am using the logarithm function and applying the formula, this product term will become summation term, okay? That's the formula. After we have written that one, observe carefully here. Emit the this term. Why? Because we are calculating maximum probability. In maximum probability, this term is getting added in all the terms. Like for example, if I have to calculate which is the highest number, 1 2 3 4 5 or 6, which is the highest number, instead of that I have here 10 plus 1, 10 plus 2, 10 plus 3, 10 plus 4, 10 plus 5, 10 plus 6, and I am adding all of this and then calculating which is the highest number. There is no point in adding this and comparing, because 10 is getting added to each number. It does not make any relative difference, right? If I remove 10 also, still I'll get the same largest number. So that's what we are doing here in this term. If you observe carefully, this is the constant value which is getting added in all the summation parts. So I'll be just removing that one, okay? So when we remove that one, we will be remaining with this formula, okay? So practice is only the key. You have to practice this more, and then only it will be staying in your head, okay? Now what we are doing, observe carefully, this is argmax. We are finding out the maximum value, but we have a negative term here. So what we will be doing is we will be removing that negative term and finding out the least value. For example, if I give you 1, 5 and 7, which is the greatest number? 7. If I tell you 1, minus 1, minus 5, minus 7, which is the greatest number? Obviously you will choose minus 1. So if I ask you which is the least number, again you will choose this same number, right? So whenever there is negative sign, we will be going with least values, okay, to get the most least value. So when we consider argmin here, just that's the difference which we made here. And observe carefully again, here we have 1 by 2 sigma square. That's also constant value, we can ignore that one, and we'll be remaining with this one. So hmap or hml, which is the most likelihood value, is given by argmin of h belongs to the capital H, summation of I is equal to 1 till m, di minus h of xy whole square. This is the final answer which you need to get 8 full marks, okay? So this is also called as maximum likelihood, also known as least error, because there is least error hypothesis, least squared error. This is the error which I am calculating, and this is the least value because argmin, and it is squared, so least squared error, and this is the hypothesis which we are considering, so it is called as least square error hypothesis. In the exam they can ask you either maximum likelihood algorithm or the least squared error, LS algorithm. Both of these have the same derivation. You have to write this one only, okay? A very important question from exam point of view. Next, this is the subtopics which might be asked in exam, or just for your information, okay? If you want, you can skip this one. Maximum likelihood for predicting probabilities, okay? How we can use maximum likelihood for predicting probabilities? What is the main criterion that should be maximized for getting the most optimal solution? So just consider f dash as that criterion which we are trying to find out. F dash in this setting is nothing but x belongs to 0 and 1, x has values 0 and 1, such that f dash of x is equal to probability f of x is equal to 1 will be the most optimal one. So here we will write p of d by h is equal to the product of p of xi comma di, given that h has occurred. Applying the product rule, there is a product rule for this one. We will be writing p of di by h comma xi, p of xi. This is the same thing in the Bayes theorem which we used, okay? Now let's see what is this one. I will find out this one, and I mean we will just find out this one and substitute that in this place. The probability, this can be given as h of xi or 1 minus h of xi based on the di value, okay? That's the third thing you need to write. Next, what you need to write, this is the expansion of this formula. This is standard formula which you need to keep in mind. So when we get this formula, we can substitute this in the equation number 2. Means in this equation we'll be substituting this part, okay, this whole thing. When we do that, what we will obtain is this one. In the place of this, just I substituted this one, p of xi is from here itself. We can write the expression from maximum likelihood hypothesis as argmax, this product of this term in multiplied by xi. Just that we wrote argmax in the first part, okay? The last term is the constant independent of h, so we can drop it. So which is the last term? The last term is this one. There is no h term here. We are just considering h here, okay? So you can ignore this one. So we'll be remaining with this one, okay? So it is easier with the logarithmic values. So we'll be again adding the log values here. And this describes the maximum criterion for any hypothesis in the given setting. okay, in the given problem setting. So this is what you have to write if they ask you about the maximum likelihood for probable predicting probabilities. Next we have the gradient search. Again, it's not important one. If you want, you can skip this one. But anyways, it's in the syllabus, so I'll be explaining you. Derive the weight training rule for the neural network learning that says to maximize the g of h comma d using the gradient ascent or gradient search. By using this, you have to maximize g of h comma d. The gradient descent g of h comma d is given by the vector of partial derivatives. Okay, this is a combination of the vectors which are partial derivatives of GHD. Okay, example will be taken here. Before that, you need to know the algorithm, I mean the derivation part. So here the partial derivative of GH is with respect to the input WJK, where the input K is mapped to the unit J. Okay, first you have to write this one. Partial derivative of G of H comma D divided by partial derivative of W comma W of JK. That summation is equal to 1 till m, and this same thing we have written here, these both things, and this things is added in between because this is dependent on this and this is dependent on this. Okay, so we'll be finding out this first, then we'll be finding out this one. For finding out this one, what we'll be doing is, in the place of GHD, that is nothing but di ln hxi plus 1 minus di ln 1 minus hxi. This is from the previous formula which we got. Okay, we'll be substituting that here, and then we'll be ignoring all those terms which are not relevant ones and cancelling out. Okay, so what we obtain is di minus h of xi. Only we will have this term di into 1 minus hx, di minus hxi. Okay, and in the denominator hxi can be written as hxi into 1 minus hxi. After that, you can cancel this one and this one, but before that you need to find out this separate value. This separate value has a separate formula which is given by this one: sigma of xi jk h of xi 1 minus h of xi jk. This we will substitute in the place of this. Okay, so what we get is, in the place of this, that formula which I just showed below, that will be substituting. When we do that and cancel out, we'll be remaining with this equation. Okay, this is what is called the gradient search to maximize likelihood of the neural network. Okay, next we have the minimum description length principle. So let's tick our we are done with the first two topics. ML, map, LS we just discussed, super important question from exam point of view. Next we are going to discuss MDL. Okay, minimum description length principle. Okay, so here what we do is, we'll be using Occam's razor, which is the shorter is the best. If we have many hypotheses, the shorter one is the most probably the best one. Okay, like that the Occam razor states. Now let's see how it is applicable to us. Most precisely, it could be expressed as h map is equal to arg max small h belongs to h, p of d by h into p of small h. Okay, after the log terms adding, we will get it as log of pdh log of ph, and then since it is log ab can be written as log AB can be written as log A plus log B, right? Log A plus log B, it can be written in this way. So we'll be writing it in the same way here, log A plus log B, and we'll be taking arg min instead of arg max, and we'll be adding the negative terms here. Okay, after we have done this one, we have to take some standard values, standard value for PDH and standard value for PH. Okay, so what is the log PH value, what is the log PDH value, what does it mean? Log PH value is the description of length. Okay, the length of h under the optimal encoding. In the optimal encoding, what is the length of h? That is called as log 2 of PH, and we'll be taking the optimal encoding as LCH. Okay, CH is the optimal code for hypothesis space H. And what is PDH? Probability of D given H has occurred. So what is the length of the training set D given the length of hypothesis H? The description length is the training data is given the hypothesis H under the optimal encoding. Then we can write LCH is equal to D by H as log 2 P of DH. Okay, just we'll make substitutions, this one and this one, in the place of this and this. So what we get is arg min LCH of H plus CDH of D, and given that H has occurred, where these two are the optimal encodings. This is all what you have to write for the derivation, and you can easily get 8 marks. Okay, this is the final value which you have to write in the similar form. So that was about the maximum likelihood, and let's tick that. So MDL is done. Let's go to the naive-based classifier. Naive-based classifier, I have considered ample amount of examples because this is a sure shot question which is asked in almost all the papers in the previous question papers, even in the model question paper. So at any cost, don't miss this one. There is an algorithm as well as the numerical. The numerical is more important, so listen carefully. Okay. So classification technique based on the Bayes theorem is an assumption independence of among features. Okay. So this is the formula which we'll be using mainly, but we'll be applying it in a large scale. Okay. So let's consider the example where a patient has cancer. Okay, like we'll get the lab reports, like it is negative or positive reports, and we have to calculate the probability that whether the patient has cancer or the patient does not have cancer. Okay, so a patient, this is the question, which is the question paper question. A patient takes a lab test and the result comes back positive. Okay, positive means there is cancer and negative means there is no cancer. Okay, the test returns a correct positive result. Now this came as positive. We are not yet sure that if the lab has correctly taken the test and given us positive, or maybe it has wrongly given positive. That possibility is also there, right? We have to consider that as well. So what we'll be doing is the test returns a correct positive result only in 98% of the cases. Only in 98% it will return correct one. If it tells positive, actually the patient has cancer. That is only in 98% of the cases. In the remaining 2% of the cases, what happens is it will tell that the patient has cancer, like a positive report, but actually the patient does not have cancer. Okay, that is the probability given here. Okay, and in which the disease is actually present, and a correct negative result only in 97% of the cases. In 97% of the cases, the lab report will be negative and actually the patient will not have cancer. But in the rest 3% of cases, they will tell negative, but actually the patient will have cancer. Okay, so these are the probabilities which are given to us, and one prior knowledge we have is like in the total population there is 0.008% which has cancer. Okay, this is the prior knowledge which we have. Does the patient have cancer or not? By using the probabilities of Naive-Bayes classifier, we'll be calculating what is the most probability the patient will have cancer or the patient does not have cancer, that is more probable. Okay, based on the given data we'll be calculating. This is a model question paper as well as the previous year 2020 means this year only 2022 question paper. Okay, so this has come, so make sure you know this very well. Okay, the available data first you have to write, like this is just for your reference. What you have to write I'll tell you later. This is for just simplification and keeping your interest in listening to this video. Okay, available data, what we have, positive and negative. Okay, the test report can be either positive or what, negative. Test report returns a correct result only in 98% of the cases and a correct negative only in 97% of the cases. Furthermore, what we have is the prior knowledge is 0.008% of the entire population has cancer. Now these things if you write, it will be very the question will become a more simplified one because all the information which is given you have noted down here and you just apply the formula and get the answer. Okay, so make sure you write this properly. After I've written this one, we have to convert this into the numerical form. The probability that the whole means this is the prior knowledge, 0.008% of the total world population has this disease, and means the population which does not have is 1 minus this whole value, right? So this is the probability of the whole population which does not have cancer. Okay, next is what is the probability that the test result is positive given that the patient has cancer is 0.98. What is the probability that the test report is negative given that the patient has cancer is 0.02, 1 minus this one. Here also, what is the probability that the patient has cancer means the test report is positive and given that the patient does not have cancer is 0.03, right? See, observe carefully what's happening. The patient does not have cancer, but the test report is saying the person has cancer. So it is in which case? In which case we consider this value? See here, the test report is saying that the person has cancer. Okay, so it returns only correct positive result only in 98% of the cases where the disease is actually present, but in 97% of the cases it is not present and it returns correct negative result. Means what it will return is negative and it will not be present, but in the rest 3% of the cases it will return negative but the disease will be present. Okay, so that's what value we have written here, 0.003. Okay, and next one is the test report. What is the probability of the test report being negative given that the person does not have cancer? This is given here only. What is the probability that the test report will be negative given that the person does not have cancer is correct negative result. In 97% of the cases it will return. If the person does not have cancer, it will return negative result, which is correct in 97% of the cases. That's what I've written here. The test report returns negative. The person does not have cancer also. It is 97% of the cases. 1 minus this one. Okay, that's all what you have to do. Suppose now we observe a new patient. There's a new patient who came and he has taken his result, and what we got is there is a positive result. Okay, means the lab report has given positive. Now how can we conclude that whether the patient has cancer or not? So we should diagnose the patient as having cancer or not, which is most probable. So we'll be applying the formulas. Observe carefully what we are given with and what they are expecting us to do. The test report is positive, that is sure value. We have got positive, and we'll be calculating in the first case whether the patient has cancer, and second it has given positive, the patient does not have cancer, which is most probable, that we will be considering. So let's write the standard formula. H by d is equal to p of d by h into p of h by p of d. So what we are trying to find out is, we have been given with a positive test result. What is given you have to write at the end. Remember, what is given where you will write at the end. Okay, what is given to us? It is given that the test result is positive, so we'll be writing it at the end. Given that the test result is positive, what is the probability the patient has cancer? Just what you do, instead of h you write cancer, and instead of d you write plus. When you write that and substitute all the places here, you'll get this answer. Keep it as such. Again, do the same thing for this one. Not cancer. What is, if the test result positive, what is the probability that the patient does not have cancer? The same thing you substitute. Again, you write, you'll get one answer. Based on these two answers, what we can conclude, which is more value, this one or this one? This is more value. Means the patient most probably does not have cancer. That's the conclusion we can form. The next question is, if there is a negative result, should we classify the patient as cancer or not? So again the same thing, same formula you'll write. Since this is negative result, we'll write minus here, and we'll consider the cases, two cases, cancer, not cancer, and we'll get two answers. We'll compare which is more, that we'll consider. Okay, so which is more? Here we got a 0.00016 and a 0.96. This is more, means this is the answer which you should consider, not cancer. In both of these cases we got not cancer, that's the correct answer. Means here also we got not cancer, here also we got not cancer. So what we'll be concluding is, whether the test report is positive or negative, based on the probabilities, most probably the patient does not have cancer. So we'll be concluding that is H map. Okay, most valid probability. And suppose you got not cancer here and you got cancer here. Okay, so what does that indicate? It indicates in that case, which we should take as H max. In this case we got both as not only, so we consider it as not. But what if here I got positive, here I get negative, means not cancer and cancer here. In that case what I should do is, I should consider this value is more or this value is more. Okay, in that case, based on that, I'll choose the H map. I hope so this is clear for you. Make sure you go through it. Super important question from exam point of view. Moving on, the second type of question, I told, right, two types of question are there. That was the first question. They'll give a word problem. Second is they can give you a table only. Okay, if they give you the table, listen carefully what you have to do. It's comparatively easy, but it's a bit calculation thing. Okay, there's a calculation thing which you need to do. Okay, so this is the first example. Totally I have taken 6 examples. Okay, for the crystal clear understanding. Okay, so watch how many is necessary for you and move on to the next topic. Okay, so let's start with the first one. Naive Bayes classifier to classify new instance of PlayTennis. Okay, so this is the table given to us. How many rows are there? How many rows are there? 14 rows. So 14 rows are given, and attributes are outlook, temperature, humidity, wind, and PlayTennis. Based on these values like sunny, hot, high, weak and all, whether the person will play tennis or not, that's given here. Okay, for each of these instances. Observing these instances, what you have to do is, I'll be telling you one new person, means the situation I'll be telling you: sunny, cool, high and strong. These 4 combinations are not present in this table. Okay, these 4 are not together in this table, but you have to use the formulas and try to calculate the probability. If these conditions are given, more probable the person will play or more probable the person will not play. For example, let's consider the simple case. If it is sunny, the person will not play. If the season is rainy, the person will play. Now if I ask you, if the season is rainy, with the person will play or not, obviously you'll see from here and tell. But what if many factors are involved? If it is sunny and humid, then the person will not play. If the it is rainy and strong wind is there, the person will play. And another one, he has worn red clothes. If it is worn green clothes, and another many instances are given. In that case, it's not that easy to tell. Like for example, if I tell rainy, humid, and a red color, whether the person will play or not, yes or no. In this case, it's not straightforward to answer. You have to consider what is this probability based on the other. All we have to check what is this probability, what is this. Based on that, we can tell the just the probability that this much probable the person will play, and this much probability is there that the person will not play. Got it? So that's what we'll be doing here. Okay. The first thing what you have to calculate is what is the final output we need. Okay, note down these points. What is the and these same points you have to apply for each question. Okay, and this is a sure shot question. So if you are still not noting down, you are the stupid person. Okay, so first thing what you have to note down is probability of no and yes, how much it is. Means this is the final output which we need, whether the person will play tennis or not play tennis. So you'll be calculating how many no's are there and how many yes are there. Okay, that probability you have to tell me. PlayTennis yes is equal to 9 instances are there out of 14 instances where it is yes, and 5 instances where it is no. These are the probabilities which you should keep in mind. After you have done that, you have to check each of these attributes: outlook, temperature, humidity, and wind. Okay, and outlook you will be writing here humidity, temperature, and wind. In that, how many outputs can be possible? Yes or no? Yes or no? Yes, no, yes, no. That's all. Okay. And inside each of these, how many distinct values are there? Sunny, overcast, rain, 3 distinct values. Hot, mild, cool, 3 distinct values. High, normal, 2 distinct values. Weak, strong, 2 distinct values. We'll be writing how many distinct values are there here. After that, observe carefully what I am doing. Sunny, yes, 2 by 9. Okay, sunny, yes, how much? 2 by 9. Why I've written 2 by 9? Whenever it is yes, how many total yes are there? First you tell me that. Total number of yes is 9, right? So I'll be writing 9 here. Out of those 9, how many are sunny? Out of those 9, how many are sunny? Let's see. There's yes here. If it's overcast, yes, rain, and yes, overcast, yes, sunny. 1 I got, rain, 2 I got. Okay, overcast, overcast, overcast. Out of the 9 yes, I have 2 sunny. So I'll be writing 2 by 9. How you have to read this one? What is the probability of having sunny as the weather given that it is yes? Again, what is the probability of having sunny given that the answer is yes? The answer is yes, there are total 9 possibilities. Out of that, there are 2 sunny. Same goes for all of this. I'll be just explaining one more, and rest all you should understand by yourself. For no, what you will do? How many no are there? Out of those no, how many sunny are there? See here. Where are no? There is no here. Is it sunny? Okay, count is equal to 1. Sunny, count is equal to 2. Rain, count is equal to 2. Sunny, count is equal to 3. Rain, count is equal to 3. 1 no I missed, I guess, here. Okay, count is equal to 3. Out of 5 no's, there is count is equal to 3. Okay, 3 times sunny has appeared out of 5 no's. So, what is the probability of sunny given that the answer is no? 3 by 5. Like that for all you have to do. Okay, so I hope so this is clear for you. I'll just take one random for your satisfaction. Strong, and let's take yes, or let's take some weird ones. Weak, yes. Okay, yes, you write how much it is. Weak, calculate in yes how many weak are there. Let's see how many weak are there in yes. Weak you have to consider here, the last column. 1, 2, 3, no, 4, 5, no, no, 6. 6 weak are there out of 9 yes available. Okay, after you have created this table, apply the formula, you'll get 8 marks. Okay, that's all. Now I have to observe carefully what is given here. Outlook is equal to sunny, temperature is equal to cool, humidity is equal to high, wind is equal to strong. We are doing for naive based classifier. Like this, many questions will come. So make sure you remember this. This is for naive based classifier. What you have to do. V of NB. Argmax Vj is equal to yes or no. Vj is the final output. J can be either yes, J can be either no. Probability of Vj, which is probability of yes and probability of no. Two cases we will consider, and we will multiply all the I terms where A of I has occurred given Vj is there. A of I can be sunny, cool, high and strong. Sunny, cool, high and strong for yes one time we will do. Sunny, cool, high, strong one for no we will do. We will calculate both of the answers. Then we will see which is more probable. That is my final answer. Argmax first we will consider P of Vj. Outlook is equal to sunny Vj, temperature cool Vj, humidity high Vj, wind strong comma Vj. Vj can be yes or no. Based on that, two cases will form. When Vj is yes, I'll get this one. When Vj is no, I'll get this one. How to substitute the values? Just see here. Yes is given. What is the probability of yes? Above only we wrote probability of yes. That's why I told you to write first. 0.64. So I'll be writing 0.64 here. Multiplied by sunny given yes. What is sunny given yes? If you listen to my explanation carefully, sunny given yes is this one. 2 by 9. Like that. Substitute for all and calculate two answers. And which is more? This is more. So the person will not play. That's my final answer. But before that, you have to present it in a nice format. Then only you will get full marks. Add these both values. Okay. Add these both values. What answer you get? Mention here. And write the yes value here. And same goes for no also. When you do that, you'll get two answers. Which is more? That's your final answer. Which is no here. Okay. So that's all what you have to do in the naive Bayes classifier. The data set. Okay. We'll be considering few more examples so to make you more crystal clear in the things. Okay. The next question is using this probabilities data set, estimate for new instance, color is equal to green, legs is equal to 2, height is equal to tall, and smelly is equal to no. Okay. This what? This is the data set given to us. How many rows are there? 8. What is the output? Output is species. What you will not find here, that is your output. Here can you find species given? No. The last column will always be the output. Okay. Now what we will be doing is, how many M are there, how many H are there? That thing we'll be writing first. How many M are there? 4M. How many H are there? 4H. So 4 by 8 and 4 by 8. Probability of M is 4 by 8, which is 0.5. Probability of H is also same, which is 0.5. That's the first thing you will write. Second thing what you will write, the attributes. Observe carefully for the attributes. Color you will write, and two things M and H you will write. Okay, you'll write, make a box like this, you'll write color M H, and inside color you will write how many distinct values are there, white and green, white, green. Then calculate how many white are there given M is there. Okay, how many white are there given M is there. M is given in the first 4, right? First 4 M is given. Given M, how many white are there? 1 white, 2 white. So it will be 2 by 4. Next is given H are there, how many white are there? 1, 2, 3, it is 3 by 4. Okay, like that you will write first 2. Second, how many green are there given M is there? How many green are there given H is there? Those two values you will fill here. Like that you will do for legs, height and smelly also. Fine. First you will write these probabilities. Then you will write these tables which I just explained you how to write. After I have written that one, what they have asked? They have asked for the new instance which is green, 2, tall and no. 4 values are there, green, tall, legs and no. So we'll write M comma new instance is equal to P of M. First you will consider for M, then you will consider for H. So when it is M, we'll be multiplying this green by M, leg by M, H by M, smelly by M. Find out the values, multiply, get one answer, keep it as such. Do the same for H, substitute the values, calculate the answer and keep it as such. Compare which is more, that's your final answer. And the final answer in this case is species belongs to H. Okay. Again, one more thing is given. Now you should answer me. What is the first thing you will do? Which is the output? This one. How many distinct values are there? 2. Yes and no. How many are there? You have to calculate and do what? Probability. So how many yes are there? How many no are there? Quickly calculate. 1, 2, 3, 4, 5. 5 yeses is there, total 10 are there, obviously 5 no will be there. So probabilities will be 0.5, 0.5. Probability of yes is 0.5, probability of no is 0.5. Next, tell me how many attributes are there. Color, type and origin. How many are there? 1, 2, 3. You have to make 3 boxes, isn't it? In 3 boxes, how many attributes means how many values distinct are there for each of these? Let's take for color. Red, yellow, and is there any other? No. Red and yellow. 2 distinct values here. Here how many distinct values? 2 distinct values. Here how many distinct values? 2 distinct values. So we'll be making a table like this. We'll be writing the first attribute. Which is the first attribute? Forgot? No. Color. Color you will be writing how many distinct values are there? Yes and no. So we'll be writing yes and no. I mean the outputs. Distinct values is this one. So we'll write here red and yellow. Next step is what? For given yes, how many red is there? Tick all the yes present. Let's do it once. Yes is present here, 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 and here. How many red are there among that? 1, 2, 3. 3 red are there out of 5. 3 by 5 will be the answer for red and yes. Same thing do for the rest also. Okay. After you have done this one, consider the new instance which is given. Red SUV domestic. Is it yes or no? Red SUV domestic means first we'll consider for yes with red is SUV domestic, then we'll consider no with red SUV and domestic. We'll calculate these two probabilities, calculate which is more. Observe carefully. Yes and new instance. Probability of yes multiplied by red with yes, SUV with yes, and domestic with yes. Substitute and calculate, keep it as such. Do for the same thing no also, substitute the values and calculate, keep it as such. Which is more? This one is more means it is no. Hence the car is not stolen. One more example. This is the theory type question. Here the theory is given. Here you have to means note down the points and convert them into formulas by your own brain. Okay, they have not given any data set here. Consider a football game between two rival teams, say A and B. Suppose that team A wins 65% of the time and team B wins the remaining matches. How many remaining matches? 65 minus means 100 minus 65, 35 times. 35% B will win. Among the games won by team A, only 35% comes from playing at team B's football field. Read it again. Among the games won by A, how many games are won by A? If these are whole games, 65% of the time A wins. So this is 65%. A wins in this case. In that, 35% comes from playing at team B's football field. In this, the 35%, which is this one, this comes from playing at B's field, which is home. For B, home is his own field. On the other hand, 75% of the victories for team B are obtained while playing at home. Home means B's field. 75% of this one, this is what B is winning. In this, 75%. This comes from playing in home itself. So, B will win this many matches while playing at home. And A will win this many matches while playing at B's field. Okay. Now let's see what is the question asked. There are two questions asked. If team B is to host the next match, means B will be his home. B's home will be playing. Between the two teams, which is A and B, what is the probability that it will emerge as the winner? What is the probability that B will win given that B will host the match? If B will host the match in his own space, what is the probability that B will win? Now you have to segregate two main events happening here. The first event is B is hosting the match. That's the first event, event A. Event B is winning or losing. That is the event B. Instead of B and A and B, let's take it X and Y. And Y is winning, X is hosting. This is the event of hosting, this is the event of winning. Now what they have asked. To know what is the events happening here, how did I write so easily? First observe what they have asked. What is the probability that it will emerge as winner? So obviously this is one event. It will emerge as winner. Now emerging as winner is dependent on one event, which is B is hosting in home or far or away, right? What is it called in football? I'm not sure. If it is home here, the second is away only, I guess, right? So home and away, these are the two other events. Winning or losing is slightly dependent upon whether it is home or whether it is away. So this is the second event which is taking place. So these are the two events which I'll take for the consideration. X is hosting, Y is winning or losing. After I've written this one, how will I write this one? Who will emerge as winner? And who is hosting? B is hosting. B is hosting means XB. X means hosting, XB means B is hosting. What is the probability that it will emerge as winner? It means whose talk we are doing now. Team B's talk we are doing. So it means YB. Y means winning and B means B is winning. XB means B is hosting. So what is this probability that we have to calculate? Understood how we arrived at this conclusion? Okay, now we'll be just applying formula, substituting the values and getting the answer. All the values are also given here. You need to just find out what is the values given. Let's have a look at that. Probability before that, Y is the winning football match, X is hosting football match, two events. Probability that team A wins is P of YA, which is 0.65, that is given to us. 65% of the times A wins. Probability that team B wins is 35%, obviously 1 minus 0.65 is 0.35. Then probability that the team B hosted the match, it has 1. Probability that the team B has hosted the match, it has 1 is B has hosted the match given that it has 1. What is that percent? 75%. Read once more. Given that 75% of the victories for team B are obtained while playing at home, means victories obtained given that they have been playing at home. Okay, so those probability I'll mark it as follows. B has hosted the match given that they have won is 75% of the time. Probability that B has hosted the match and team A has won, that is 35% of the time. Right, if you read the question there, you will get it as 35%. Team B hosted and team A won. What is the probability? Read the sentence, you'll know. Among the games won by team A, only 35% came from playing at team B's football field. A has won given that B has hosted. Okay. What is hosting? Hosting is XB, right? And winning is YA. So here I'd make a slight change here. XB it should be because B is hosting, and YA because Y is winning. Okay, this is XB by YA. That is 35%. So we'll just substitute these values. What we have to find? YB by XB. Given that B will win and B has hosted, means what is the probability that B will win given that it has hosted? So we'll apply formula, see from the above the values, and we'll substitute that. And XB is nothing but XB by YA into YA, XB by YB into YB. All values have been given. You can just substitute and find out the answer. This is the probability that 1 by B. Now you have to calculate the probability 1 by A as well. 1 by A, just write here YA instead of YB in the above formula. In this formula, just write YA here. And then calculate these values and you'll get one answer here. And 1 by A. Which is more? 0.4 or 0.5? Obviously, this is more. So the probability of B winning will be more given that B has hosted the match. Fine. Okay, and the next question also was also same only. If B has hosted the match, who will be emerge as the winner? Same question only. Okay, so this is the answer. And this is how you do the stuffs. Okay, first read the question, get the what they have given, note it down, convert it into formulas, and then find out what they are asking. By that you will get the events, and once you get the events, write down the probability values, use the formula, substitute, and find out which answer is more. That's your final answer. Okay, let's have a look at one more question, which is use Navier classifier to classify A is equal to 0, B is equal to 1, C is equal to 0. This is what new instance given to us. Now tell me, what is the output? This is the output. How many values are there? Plus and minus means two values are there. Count and tell how many plus is there, how many minus is there. How many plus is there? 1, 2, 3, 4, 5. 5 plus is there, total 10 values, 5 minus will be there. That means 0.5, 0.5 are the plus and minus probabilities. How many attributes are there? 3 attributes are there. Which are those 3 attributes? A, B, C. Keep everything simple, very simple. Don't take it to head, don't hurry. Ample amount of time is there. Easily do this question. Sure shot 8 mark question. Okay. A, B, C are given. And in A, how many distinct values are there? 0, 1. In B, how many distinct values are there? 0, 1. See how many distinct values are there, 0, 1. Okay, so what you'll write, A you'll write here. What is the classes, plus and minus? How many distinct values are there, 0, 1? What is the probability of A having a 0 given that it is plus? Tick all the plus. In A, how many 0 are there? 1, 2, 2 only. 2 out of how many plus were there? 5. Got it? What I am writing? Same as previous one. Same I am writing. Calculate this ones also for A, B and C, and I'll obtain 3 tables. And one instance is given here. We have to calculate this instance, 0, 1, 0. This is the instance, and 0, 1, 0 is not explicitly given here. That's the only we need to calculate, right? Otherwise we'll just see here and write it's plus, means it is plus only. Since 0, 1, 0 is not given, that's why they have asked this question. Okay. And for finding out this one, 0, 1 and 0, for 2 cases we'll find out. First for class plus and second for class minus. Probability of plus given new instance, probability of minus given new instance. That is nothing but probability of plus is 0 by plus, A is equal to 0 by plus, into B is equal to 1 by plus, into C is equal to 0 by plus. Substitute values, find out the answer, keep it here. Do the same for the negative also. Substitute, find out the values and tell me the answer. That will be 0 here in this case. This will be 0.008, which is more, this is more. That means plus class is the most probable value in this case. Okay, for the new instance, what class we have to assign here? Most probability is plus, so we'll be assigning plus value. Got it? Okay, so let's move on to the last example, which is example 6. By now I hope so that things are clear. Even if not clear, you can listen this example. Hopefully the things will be clear for you. So answer me, what is the output class? Bias computer is the output class. How many no are there, how many yes are there, that you have to calculate. In this, how many attributes are there? 4 attributes are there. How many distinct values are there? Here I guess 3 distinct values, and 3 and 2 and 2 I guess. So based on that you have to find out and count and do the same things what I did previously. After you have done that, the new instance is given to us. Age value is given, income is given, student is yes, and credit rating is given as fair. So we'll be considering for 2 cases, one for no and one for yes. So let's consider it as E1, E2, E3 and E4. Okay, for shortcut, yes by E is new instance, so E1 yes. Also we have first multiply P of yes. P of yes will be multiplied with E1 yes, E2 yes, E3 yes, E4 yes. Calculate an answer and keep. E1 no, E2 no, E3 no, E4 no and no. Just calculate it and keep. And this is the table values from which I have inferred. Substitute and multiply, you'll get one answer. For no and yes, which is more, that's your final answer. For yes, what you got? 0.0028. Here 0.007. So for yes it is more, therefore he will be buying the new computer. Fine. So that was about the wave-based classifier. Super important question from exam point of view. Make sure you don't miss this one. 8 to 10 mark question. So practice this well. If you did not get at any point anything what I explained, rewind that and watch it again. Okay. So let's get done with this one. Ticked. Now 2 simple theory questions are left. We'll complete that also and go to sleep. Rest. Okay. The next topic is Bayesian belief network, and then we have the EM algorithm. So whatever is given here, that I have written the numericals also in this case just for your reference, but in the exam they'll just ask the theory things. So I'll be telling you what are the theory things you need to keep in mind, what are the key points you need to keep in mind. The theory example is just for your remembering, because if there's no example given, you just read the all the stuff like this like a robot, nothing will go in your head. Okay, example will make the best way to keep the things in mind. So here is a burglar alarm system. So what happens is, if there is an earthquake or a burglary, okay, so in that case there will be alarm sounding, and the alarm is heard by 2 people, Mary and John. If any of these 2 people hear the alarm, they will call the owner of the house. Okay, make a call. So okay, you got the scenario right. So what happens is burglary and earthquake. When these happens, alarm will be sounded. So alarm is dependent upon two events, which is burglary and earthquake. And the call made by Mary and call made by John is dependent upon the event, which is alarm. If the alarm is sounded by Mary, it will be sounded. If the alarm is sounded by John, means if the John hears an alarm, he will make a call to the owner of the house that there is a burglary in your house or the earthquake has happened. Okay, and the probabilities are also given. Burglaries probability is 0.01, earthquakes probability is 0.002, and the alarm probability is dependent upon two things, right? Earthquake and burglary. So if burglary and earthquake both will happen, alarm will sound 95% of the times. If burglary happen but the earthquake does not happen, it is 99% of the time it will sound. If burglary did not happen but the earthquake happen, it will sound 29% of the time. If burglary and earthquake both does not happen but still in 0.01, 0.11%, 0.001% of the time the alarm will sound. Okay, so whenever there is a dependency on of this thing upon two things, they will be writing this table, because this can be true, this can be false, there can be four combinations. So all these combinations you have to mention here. Same goes for the Mary calls and John calls. In Mary calls, whether alarm sounded or not sounded, those are the two events. So alarm sounded, not sounded, probability that Mary will call if alarm is sounded is 70%. If the alarm is not sounded, Mary will call is 0.01%. John call 90% of the time. If the alarm is sounded, John does not call. If the means John calls if the alarm is not sounded 5% of the times. So these probabilities are given to us. Let's see what is the question. The question is, what is the probability that the alarm has sounded but neither burglary nor an earthquake has occurred and both John and Mary call? In the naive Bayes classifier will not do in this way. In the Bayesian belief network we will be having an acyclic graph. You have to make note of 2 points: acyclic graph, ACG, and CPT, which is computational probability table. Okay, so these two things are the main representations of Bayesian belief networks. In this we'll be using acyclic graph. Okay, acyclic graph means this is not having any cycles in it. That is what is called acyclic graph, and computation probability table is nothing but these tables which we have written here. Okay, these are called as probability computation probability tables. By using these two we have to calculate. Now segregate the question into different parts. What is the probability that the alarm has sounded? So alarm has sounded is A. Neither burglary not earthquake has occurred, not B not E. Okay, and John has called, Mary has called, so JM. So what is the probability that all these events are happening? That we have to write. So that's the same thing I'll write. John and Mary, alarm has sounded, burglary has not happened, and earthquake has not happened. What is that probability? How to do that is, J means what? John has called. John has called depends on alarm. So John has called alarm, I'll write like this, J by A. And Mary has called, that also depends on alarm. So I'll be writing M by A into, and alarm depends on two events, which is burglary and earthquake. But burglary and earthquake both did not happen. So burglary and earthquake I'll write not B and not E. And finally I'll write probability of burglary did not happen and probability that earthquake did not happen. All these probabilities I'll write here. See the table, substitute the values, I'll get the final answer. You need not worry much about how the values are substituted. Just observe carefully what I am doing. I have a acyclic graph. How I am writing these values based on how many it is dependent upon, and using these values how I am calculating the answer. Multiplying each of these terms wherever it is dependent on whatever the terms are given here. Like that we are calculating the final answer. This is how Bayesian belief network works. Okay. Then again, what is the probability that the John calls? Probability of John call is given by PJ. Probability of John call depends on many factors. John call means there can be alarm sounded or alarm not sounded. That's the first segregation. Yes or no in the alarm level. If it is yes or no, in both cases it can be burglary yes, earthquake yes, burglary no, earthquake yes, earthquake no, burglary yes, burglary no, earthquake no. Four possibilities for this one, four possibilities for this one, right? So totally 8 possibilities are there that all I have to calculate. So that's what I will be writing here. P of j by a given that a has occurred, P of j not a given that not a has occurred. In each of these 4 are there. Just now I mentioned what are those 4. So all those 4 possibilities I will be writing here for this one. Then for this one also I will be writing 4 possibilities. Totally 8 possibilities. Substitute the value and get the final answer. That is the probability that the John will call. Next we have what is the probability that there is a burglary given that John and Mary calls. Now this is a reverse question. In this we have been given that there is a burglary or not, that you have to find out given that John and Mary calls. In this we have to go in a reverse manner. In the reverse manner, how we will do, we have been given with the evidences and their values. Evidences are John and Mary calls, values are true and true. John call is true, Mary call is true. For that we will be using this formula. Probability of x given the evidences, x means whether the burglary has happened or not. This is burglary has not happened, happened not happened. These two will calculate and compare. That is equal to this all things which is given in numerator divided by except x, all these probabilities. Like that we should also consider an alpha term here. I will tell you what is alpha in the next means sentence. So these are the two formulas which I have to calculate. Now let's see what is alpha. Alpha is nothing but 1 by probability of x happening, probability of x not happening. So we'll be calculating each of these. Okay, burglary has happened, x is nothing but burglary, and jm means John has called, Mary has called, and we have to use this formula. There can be two instances, whether the John and Mary has called for alarm yes and for alarm no. So two possibilities are there. So for that I have written summation a here. A can be called or not, means alarm sounded, alarm did not sound. Same goes for these events also. Probability that the alarm sounded given that burglary and earthquake happened, and burglary and earthquake did not happen and alarm sounded. Okay, so 4 here and 4 here. All these I'll note down here. You need not worry what I have noted down. You got the point, right? What I am noting down. One case I'll consider alarm sounded. One case I'll consider alarm not sounded. Substitute the values, find out the final answer, and you'll get one term here. Find out the alpha value and just multiply. You'll get that answer also. Compare which is more. That's your final answer. In this case, the final answer is not a burglary has happened. If John and Mary call, there's probability more that burglary has not happened. Okay, given on the basis of probabilities, we got these two answers, which will finally compare. You got the overall working of this, right? That's more than enough for you. If they ask you about the exam, just briefly write. You'll get 8 marks, hopefully. Okay. Here's another one. If you want, you can listen to this one, or you can skip if you have got the concept how it's working. This is the example of battery, gauge, and fuel, start car. Okay, so see here there is a gauge, okay, and battery and fuel. Based on the battery and fuel, gauge is dependent upon. Okay, gauge can be empty or full, and the same thing goes for start. Car can start or not start based on two things, fuel and battery. See, this arrow is here, this arrow is here, means gauge is dependent on these two. Battery is going to start and fuel is going to start. So the start is dependent on fuel and battery, but there is no connection between gauge and a start, so I should not consider that one. And the probabilities given here are b is equal to bad, battery is bad, probability is 0.1. What is the probability that battery will be good? 1 minus 0.1, obviously. So the probability of battery being good is 0.9. Same goes here also. Fuel is empty is 0.2, fuel is full is 0.8. Like that here, since gauge is dependent on battery and fuel, so I'll be writing here when gauge is empty, b is good, f is empty, b is good, f is not empty, b is bad, f is not empty, b is bad, f is empty. All these probabilities is given here, and same goes for whether it is not empty. If it is not empty, just do 1 minus this one, 1 minus this one, 1 minus this one, and 1 minus this one. So you'll get when gauge is not empty in each of these cases. Same goes for start also. Start is no, 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 no. If you want yes, 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 multiply 1 minus this. Okay, now they have given a new instance, which is b is equal to good, battery is good, and fuel is empty, gauge is empty, and start is equal to yes. In this case you have to calculate what is the probability of this instance. And second also one probability is given. Third is given the battery is bad, compute the probability that car will start. If the battery is bad, in that case what is my probability that the car will start? That I have to calculate in the third question. Let's have a look at one by one. The first question is the new instance b is equal to good, f is equal to empty, g is empty, and s is yes. If this is given, what we used to do, multiply this one with this one. Wherever it is dependent, we have to use that. Gauge is dependent, so gauge is dependent on battery and fuel, and battery is good and fuel is empty. So I'll write gauge is empty given that battery is good and fuel is empty, multiplied by s is yes, as s is dependent upon these two, right? So see, what I'm trying to tell is start and gauge both are dependent upon these two. So we cannot just write gauge empty answer. Gauge empty based on these two we have to write, and those two values are given, good and empty. So this is empty and good and empty, so this is the value which I consider 0.8. okay, so that's why I've written here 0.8. okay, third value is 0.8. Same goes for this one also. When it is yes and b is equal to good and f is equal to empty, in that case what is the probability? Up only you can find out, you can see and write, this is the answer which you get. So observe carefully what's happening. What are the values that are not dependent? Those you'll write directly. The answer is given, right? These two values are nothing but these two values. See here, these two values only. Okay. So that values I'll be writing here, and I'll be calculating which is dependent. Dependent value is also given, just see and write. Only in Bayesian belief network, seeing and writing is your only task. Okay, but numericals are not asked in exam, so you need not worry. Just explain the theory parts, how it works. Okay. Here also you'll do the same thing, and here given that battery is bad, what is the probability the car will start? So how I can represent that? What is the probability that the car will start given that the battery is bad? Okay, so here also I'll be doing the same thing. This you can just ignore for now. Okay, just don't mind. And we'll be considering this which is dependent, S and B, which is dependent upon S and B. S is dependent, right? Why? S is dependent upon fuel and battery, right? S is dependent upon fuel and battery, but battery is not dependent upon anything. See, above this nothing is there. So for S we have to write fuel and battery. Since battery is already given, we'll just write another thing, fuel alpha. Alpha can be either empty or not empty. Two cases we'll consider. Okay, after I've written these things here, then I'll be writing one for empty, F is equal to empty, and F is equal to non-empty. I'll substitute the values, add it up, and I'll get the final answer for car will start given that battery is bad. This is the probability, 0.08. Okay, I hope so. Bayesian belief network is clear for you. Just mention the theoretical concepts, and you can refer the official notes. In that the concepts are given in the sentences are given. You can go through that for capturing the key points. I just had to explain you what it actually means and how it is applied in real life examples. Okay, with that you can get some idea and fill the content. We have been done with Bayesian belief network. Okay, so after Bayesian belief network, the last topic remaining is EM algorithm. So to understand EM algorithm, you need to understand three things, which is k-means classifier, and second is one more is there, and after that Gibs algorithm is there. So these three things which you base optimal classifier. Okay, unless you understand these three things, the EM algorithm is hard for you. So these are the three things which you need to understand for understanding the EM algorithm. So and among these three questions, all these three questions are there in the model question paper as well as in the previous year question papers. Okay, so the final four topics are all super important. Okay, so let's get started. We'll be discussing the key points in each of these. K means clustering algorithms, the steps and the derivation, and the example you have to write. Okay, example you can give it by your own itself. The previous semester in the data mining you have learned, right? Or else also the steps are sufficient. You can explain by steps also what's happening. So K means is an unsupervised learning algorithm. In this, a set of data items are given. Okay, many data items are given. It categorizes the items into k groups or clusters of similarity. Okay, so these data items are classified as different groups. How do we do that? By using Euclidean distance, Manhattan distance, Hamming distance, or cosine distance. Okay, and what is the pseudocode for it? First, we will get k number of clusters and the list of data points. Choose k number of random data points. Like if these are all the data sets given to us, we'll be choosing k points here. Okay, like 1 point here, 1 point here, 1 point here. After that, repeat until a cluster center stabilize. Okay, allocate each point d to the most closest with the centroids, and then compute the centroid for the cluster using the all points in the cluster. For each of these points, what is the closest point, you have to assign that, and then again calculate what is the centroid. You'll get a new centroid for this one. When you get a new centroid, again consider all the points and assign which is closest to it, and for all these same points you have to do again and again until these all stabilize. Okay, that's all what is the k-means algorithm is. You can draw the flowchart if you want. What is the advantage of k-means algorithm? Easy to understand, simple, easy to implement, efficient, in which the cluster points are linearly data, and there's no other clustering algorithm better than k-means. Disadvantages: user has to specify the initial k value. All the process may not converge at the end. There might be similarities, and it is not suitable for discovering clusters that are not hyperellipsoids or hyperspheres. Okay, in these two cases it is not applicable. So that's what you have to write about the k-means algorithm if they ask in exam. Base optimal classifier is just a variation of naive Bayes classifier. Here we will be getting the most probable prediction for a new example. Okay, P of A by B is equal to P of B by A into P of A by P of B. This is the general formula which we have. For any dataset, we have two things: x1, x2, x3 are the attributes, and y or yes or no are the output or the target functions. So this we can write in this form. The same formula is used here: x1 by p1 x2, sorry, x1 by y, x2 by y, xn by y, that's all I've written here, into p of y by these all terms without y I've written in the denominator. Okay, so this is the formula which we'll be using, and that can be simplified as follows. And this is optional since we are finding out the optimal value. We can ignore this one. So this is what we will be writing in the base optimal classifier. Okay, this is the formula which we'll be using. Let's understand this by an example. Observe carefully what is there. P of y is there, and p of xi by y, x2 by y, x3 by y, and so on till xn by y is taking place. Okay, so here some attributes are given like outlook, sunny, outcast, rain, and temperature, hot, cold, mild, and yeah, hot, cold, and mild. Play is given to us, and the thing which is given to us is sunny and hot. So sunny and hot, yes, or sunny hot, no. Those two calculations should be done. Sunny hot, yes. It will be given by sunny by yes, hot by yes, and into p of yes. All these values are given here. You can go through it. That same thing we can write it here, and we can find out the answer for no as well. Which is more, that's the final answer. So in this case, the more answer will be probability of no is more. So the answer is that player will not enjoy the sport given sunny and hot. Okay, so this is how the working of base optimal classifier is. After that, we have the Gibbs algorithm. This is used for more values. Okay, base optimal classifier is used for few values. When there are more values, we'll be using Gibbs algorithm. So we'll be using two things. We'll be choosing one hypothesis at random according to P of h by d. When we do that, we'll be using it to classify in the new instance. There will be errors in this also, but it will be far less than the errors in base classifier. For example, error of Gibbs is equal less than or equal to 2 times the error of base optimal classifier. Sometimes it might be equal also, but more times it will be less only. So this algorithm is same as the base optimal classifier. After knowing these two things, you can easily understand the expectancy maximization algorithm. Super important question from exam point of view. This is the last topic of this module. In real world applications of machine learning, it is very common that many features are available for learning, but only a small subset of them are observable. All the features are not observable to us. Expectancy maximization is used when there are some features which are not observable, but they can be inferred. Okay, expectancy maximization algorithm can be used for the latent variables that which are not directly observable and are actually inferred from the values. Okay, inferred from the other observed variables. In that case, we'll be using the EM algorithm. So we'll be writing the algorithm as follows. The algorithm is actually used for many unsupervised learning algorithms in the field of machine learning. For unsupervised, we will be learning this one. Okay. And algorithm goes as follows. Given a set of incomplete data, consider a set of starting parameters. There is incomplete data given to us. Consider a set of starting parameters. Choose any parameters and consider that as starting parameters. Next is expectation step. Use the observed variable available data for the data set. Estimate the values of the missing data. Okay, that's the first thing we'll be doing. Estimate the values of missing data. Then maximization step or the M step. Complete the data generated after expectation step in use to and use it in order to update the parameters. Use the missing data what you guessed in the data set and then maximize the data. If in step 2 or 3 it doesn't converge, you have to repeat step 2 and 3. In the flowchart, you can write it as follows. Start, initial values, execution step, minimization step. Converged, is it converged all the values? If it is no, again repeat the steps, else stop. EM algorithm can be used for filling the missing data, and it can be used as a basis of unsupervised algorithm. It can be used to estimate the hidden parameters or the hidden Markov model values, and it can also be used for discovering the values of latent variables. Its advantages include its likelihood increases with each iteration. Each step and n step are pretty easy for implementation. Solutions offer exist in the closed form. On the other hand, the disadvantages include it has slow convergence and make the convergence to local optimize only, and requires the probabilities both forward and backward for the optimization. If at any point you get any doubt, ping me on Instagram and hit the like button, subscribe to my channel for more videos like this. And thank you so much for watching. I'll see you in the next one.